My dear students, never ever scroll. You will lose a super simple shortcut here. I got in Prism. You can just imagine a light ray enters into the prism, right angled prism, making 90 degrees. It strikes the other end. Here it is, silvered. It strikes and retraces back along the same path. That means it is striking exactly 90 degrees. What does it mean here? That means I2 is equal to R2 is equal to 0. And you know the famous equation for a prism, R1 plus R2 is equal to A. R2 is equal to 0 means this part has been cancelled. That means R2 is equal to A. A refracting angle of a prism A, which is nothing but 30 degrees. Then you can just apply the simple Snell's law. What is that? Mu is equal to sin I by sin. Sin R is 30 degrees. Sin 30 is 1 by 2. And mu value is going to be root 2 here. That means sin I is going to be root 2 by 2. Therefore, sin I is going to be 1 by root 2 because this gets cancelled here, which is going to be root 2. That means sin I is going to be 1 by root 2 means I is going to be 45 degrees. Don't scroll. Let me discuss how can you find out acceleration and tensions in this type of multiple pulley cases where we need not use any free body diagram. Directly can find out an acceleration. Here you can just see acceleration is nothing but downward forces minus upward forces. Here 4 kg. 4 into g is 40. So 40 minus 2 into g is 20. Divided by net mass. Net force by net mass means you can just add them. This is 6 going to be. So acceleration is nothing but how much here? 20 divided by 6, which is nothing but 10 by 3 meters per second square. It is going to be an acceleration. You can find out the tension here. These two blocks are heavier, moves down. This is moving upwards. Here tension downwards, if you find out this one here, it is going to be 2 into G minus A. M into G minus A. Tension downward means M into G minus A. That is 2 into G is 10 minus A is nothing but 10 by 3 here. It's nothing but how much? Tension T is equal to 40 by 3 here. That is tension. If you want to find out the tension here, these two are different. If you consider this is T1, you can take this as T2 here. Okay, this is the tension T2. Different tensions, different ropes, different tensions. Here T2 is nothing but this is going upwards. So tension upward is nothing but M into G plus A, which is nothing but 2 into 10 plus 10 by 3. Okay, so like that you can find out the acceleration and tensions in these cases. Thank you. My dear friends, don't scroll. Let me solve this problem without free body diagram in just fraction of seconds. You can just see here is asking us to find out an acceleration of a system. These two blocks downwards, this going forward. That's it. Now acceleration is nothing but, you just remember one thing, friction is acting backwards, which is mu mg, and that is going to be 10 newtons. Acceleration means downward force minus friction force. Downwards 16 newtons because 2 plus 4 6 into g 16 newtons minus this is 10 divided by net mass. Total masses you have to add, which is nothing but 10 here. You are getting 5 meter per second square. Now you need to find out T1 and T2. It is going downwards. These bodies are moving downward with an acceleration. So we have to write M into G minus A. If they were going upwards, it is M into G plus A. Now we write, my dear students, T1 is holding only 4 kgs. So we write 4 into G minus A because it's coming downwards. So 10 minus 5, which is nothing but 4, 5, 20 newtons. Whereas T2 means it is holding 2 plus 4 combined together is going to be 6 here. 6 into 10 minus 5, which is nothing but 30 newtons. That's it. My dear students, I am going to teach you such a method where you will solve only 5% of problem and get 100% of results. What is that method here? According to law of homogeneity, we have to find out the values of A, B and C here. You all know the dimensional formula of C will be equal to dimensional formula of T according to law of homogeneity. And C value T is only for D option. Remaining C values are not T. So directly you can keep D option as the answer. Thank you very much. Dear students, this is an inclined plane with the concept of friction added to it. Now you can just see the block 5. Coefficient of friction is also given. Then how many forces are acting on this block on the inclined plane? One is mg sine theta is acting, that is 37. You'll be getting 30 newtons in this direction. Even friction is also acting in this direction. Friction is nothing but mu mg cos 30, which is nothing but 20 newtons you are getting. So 30 and 20 acting in this direction, only 100 newtons is acting. Okay. Then what is an acceleration here? Acceleration is nothing but these two differences. That means 100 minus 50. Net force means difference in the forces divided by total mass here. Total mass is nothing but 5 plus 10, which is nothing but 15. So acceleration is nothing but 50 divided by 15. So which is nothing but 10 by 3 meters per second square. Now what is the tension in this case? So tension is nothing but M into G minus A because this is coming downwards, so M into G minus A. If it is going up, plus you'll get. So coming down, so M is nothing but how much? 10. Into G is 10 minus A is nothing but 10 by 3. Which is nothing but 200 divided by 3 newtons. No free body diagram is required. Just a simple method this is. My dear friends, this is a rope and this is a block. We are pulling with force P. Then what is the contact force between the rope and the block of mass capital M? The simple thing you have to remember here is acceleration of both the systems are going to be same. ये दोनों का acceleration same है. When acceleration is going to be same, then what is the contact force? Here, you should remember one thing, that force is directly proportional to mass when acceleration is constant. Then what is the force here? The total force is P and the contact force is going to be Fc. And Fc is pulling capital M and P is pulling both small m and capital M. So small m plus capital M divided by capital M. This is the concept here. Then you need to find out what is Fc is going to be capital M into P by small m plus capital M. This is going to be the contact force. Thank you very much. My dear students, don't scroll. How can you solve this type of a complex systems in a super simple way? First thing is, you need to find out a common acceleration for all the blocks which are moving forward. And the common acceleration is net force by net masses. Net force is capital F and net masses are nothing but all the 4 masses which is taken as 4m here. If you want to find out what is the tension T1, this T1 is pulling 3 masses, so we write 3m into A because all the masses are going to be same. If you want to find out T2 is pulling only 2 masses, you have to write 2m into A. And T3, if you want to find out it is pulling only a single mass, so you have to write m into A. This A value substitute in all the 3 cases, then you'll get in the final answer. For example, if you substitute in T3, you'll be getting m into A. A is nothing but F by 4m. Let's cancel. So T3 is equal to F by 4. Okay. Similarly, you can find out T2 and T1 also. Thank you. My dear students, how can you find out acceleration and tensions in this type of systems where we need to avoid free body diagram and solve the problem in a super simple way? First thing is, you need to find out an acceleration is nothing but difference in the forces. Force is nothing but m into g. This is 3 into g is 30. This is 2 into g is 20. Divided by total mass, you have to add all the 3 masses, which is going to be 10 here. And you'll be getting how much? 1 meter per second square is going to be an acceleration. Now this moves up and this body comes down. When a body moves up, tension is considered to be m into g plus a. Okay, which is nothing but 2 into 10 plus 1 because acceleration we got it as 1. So this is going to be 11 to 22 newtons. Now you need to find out the tension downward when this block is moving downwards. So tension down is nothing but m into g minus a is going to be the formula. As it is going down, you have to consider the mass of this body and 10 minus 1. Okay, 9 3s are 27 newtons. Here the tension is 27 newtons and here the tension is going to be just 22 newtons. These two tensions are different because these two ropes are going to be different. Thank you.